Hey guys, welcome back to another calculus video with Mr. Soto. And today we're going to be going over composition of functions. In class we went over combinations of functions, which is when we add, subtract, multiply, or divide functions. So it's just the rules around that. But composition of functions is when we kind of put a function inside another function. As it says here, the composition of function f with another function g is known as f of g. I know that it looks like it says fog, but it's actually pronounced f of g of x equals when you put g of x inside f of x. So I'm taking one function and I'm kind of putting it inside another function. So that's why it's a composition. You're composing them together. And so it's a very easy topic if you kind of remember, but I want to make sure we got this down. So just kind of to think about, the second one is the input and the first one is the output, or the outer one. I don't want to call it an input output because it's not, but the first one here, this is the outer shell, I guess, and the pink one, so I'll even write that down, the outer shell, or the outer function, so I'll call it. And the pink one here, I did it backwards colors, but whatever. That pink one there is the inner function, or the inside input. Inner function. And whichever you want, whatever word works for you. You could say the input of this input, or I don't know. I think this is the inside and that's the outside. That's the way I think of it. And so whenever you're doing this, you want to make sure you're keeping track of what's your x's or what you're plugging in, because it's easy to make mistakes, especially when you get to the harder ones. So I'm going to quickly go over a couple of examples real quick here, and hopefully this makes sense and it kind of brings back your memories about this stuff, which you kind of learned in algebra 2, but I know it's been a year or two, so I want to make sure we do have this down because this is a big part of calculus. So let's start with the first example here. We have f of x equals 2x squared, and we have another function g of x that's equal to 3x. So we're gonna go ahead and do the first one here. It wants us to find what f of g of x is if these are our two functions. So again, remember, the second letter is the one that's going inside. The first one is the outer shell, or the outer function. So I'm gonna start with f first, but instead of putting a x there, I'm gonna take that x off and put a placeholder. So I'll even do it in different colors so you kind of know what's what. All right, so the outer shell, I'm gonna do it in blue. So the f is gonna be in blue, and the g is gonna be in red, so that you know, wait, where are these coming from? All right, so the outer shell first is 2x squared, but instead of x, I'm gonna leave a placeholder like I said earlier. So I'm gonna write 2 parentheses squared, because it's x squared, right? But I need to put something inside of that parentheses, and that's where that inner function comes in. We're putting g inside of there. And g, we're not going to write g though, we're going to write whatever g is equal to, or g of x, the function g of x. And that is equal to 3x. So that 3 of x is going right where that x was supposed to go. So I kind of inputted g inside of f. That's what essentially the math that I'm doing there. I put g inside of f. And now we just simplify. Be careful when you simplify. I know you want to quickly say 2 times 3, but before you do that, remember 3 is being squared. I'm sorry about the lighting there. But 3 is being squared before you multiply. Remember, PEMDAS, exponents go first. So I'm going to drop the 2 down because he's still there. We didn't get rid of him. And I'm going to go ahead and what is 3 squared? That is 9. Good. And then x times x is just x squared. Okay, so I got 2 times 9x squared. And now you could multiply and combine everything together. Now you can get rid of those parentheses. So now we end up with, and I'll write that answer here, we could write f of g of x is equal to 18x squared. And that is my solution here, and I'll kind of underline it for you. Or you could highlight it, or you could just leave it like that. It doesn't matter. So our solution, or our simplified expression for f of g of x is 18x squared for the first example. Now for number 2, it's backwards. They want us to find g of x. So this time f is the inner function and g is the outer function. So you're going to do it exactly the same way. F is still our blue function and g is our red function. I know it's kind of hard to see in the video, but just to kind of keep track, remember now red is the outer shell this time. So I'm going to go ahead and copy g first. So remember, you get rid of that x. So I'm going to write 3, but I'm going to leave a blank for x there because we don't need the x anymore because we're inputting f there. I'm going to put f instead of x there, or whatever the function f is, not a letter f, sorry. Now that gets confusing. So f is 2x squared. So that's what I'm going to put in those parentheses here. So this is 2x squared inside. Sorry, there's white out there because I'm dumb. It's 3x squared. And now we can just simplify. And this one's a lot easier because there's no square to deal with. Well, it is there, but it's not messing with our function. So all you gotta do is multiply. What is 3 times 2? That is 6. And then we bring down the x squared. So that's all I can do. So the final answer for this would be g of f is equal to, oops, sorry, I completely forgot the x there. Let me just pretend like I didn't make that mistake. Equals 6x squared. And you can kind of underline it or whatever just to know that that's the answer. Alright, so simple enough. Hopefully that makes sense. I'm going to do these other examples too, just because those are the easy kind, but of course you're going to see some more difficult. Just 3 more examples and then I'll let you work on your own. But let's go ahead and do number 3 now. Now we have new functions, f of x equals plus 4 and a g of x equals x squared plus 1. So whenever you're doing this, make sure you're following your PEMDAS rules and all that, because that still comes into play. Math just doesn't stop when you get to higher math. The math rules always apply, you know. And so again, our f is the outer shell or the outer function and g is the inner function this time. So I'm plugging the g function in to the f function. So remember, all that means is every x you see, you're just going to replace with the g function. So in this case, let me see if I have the correct pen here. So in this case, I'm going to write, I'm going to even leave a space here. I'm going to write blank plus 4. Because that's where x is supposed to go, right? X plus 4. But I'm leaving a big blank for my g function, because that's where I'm taking this function and I'm putting it where x is supposed to be here. Okay, like I'm taking it and shoving it in there. And so I should have done it in blue, but whatever, I'll just put the g in red. What goes inside is x squared plus 1. And this one's fairly simple too. From there you just combine like terms. So I'm gonna take the only like terms in this example. Sorry, the lighting is so bad in this room right now. The 1 and the 4, and you're just gonna combine those, and you should get x squared plus 5. And to be formal, you do have to write that at the end. You write f of g of x is equal to x squared plus 5. So basically what this is saying, the composition of f and g turns to this. If I compose these f and g functions together, they create this new function called that is x squared plus 5. So you're composing 2 functions together. Same thing with number 4 here. It's just the backwards version of it. This time I'm putting f inside of g. So let's start with the outer shell. You always start with the outer one. That is x squared plus 1. Remember, every x you see just gets replaced with parentheses. That's the way I think about it. So I'm going to go ahead and write that here. I think I'm going to need a little bit more space for this one. So I'm going to go right there. Instead of x, I'm putting a squared right here. Plus 1. Because that's what g is. G is x squared plus 1. Okay. Then I'm going to take f, and I'll use blue for that one, because f is in blue. Right? I kind of leave. I'm putting f inside of here, and f is just x plus 4. Nice. So you just put x plus 4. Now, there's a reason I did this example, because this isn't as easy as the first one, the 3. It's going to recall some linear, some algebra stuff that I haven't gone over, and hopefully you do remember and you should know. But I'm always the safe teacher. I love making sure everybody knows everything before I get to new topics. So in this case, we got x plus 4 squared. Now, that doesn't mean it's just x squared plus 16. No, you have to do either the box method or double distribution. And so you did it in a combination of functions. So it's actually going to be, if you think about it, it's going to double distribute. So it's basically saying x plus 4 times x plus 4. Then you still got the plus 1. And then you start simplifying. And when you simplify, just be careful. I kind of went over it in combination. You do x times x first. Then you do x times 4. Then you do 4 times x and 4 times 4. You double distribute. That's what I called it. They might have called it the box method. They could call it I don't know, the T method, I think I've heard. But it's however you feel comfortable doing it. Just make sure you're multiplying correctly. So if I do work it out, I do x times x, that's x squared. X times 4, that's 4x. 4 times x is another 4x. And then 4 times 4, that's 16. And of course, there's still a plus 1 at the end. So don't forget to add that plus 1 towards the end. And then we just combine like terms. So I'm going to put the ones that go together. This 4x and this other 4x are in the same family. So you put them together. While this 16 and this 1 are in the same family. So you put them together. X squared is a loner, so he gets to lead the pack. Make sure I'm going to write that g of f because I'm already done pretty much. So g of f of x is equal to, let's combine like terms. So x squared goes first. And then 4x plus 4x, that is 8x. And 16 plus 1, that's 17. And so there you have it. That's our composed function of g of x for that one. Hopefully that didn't destroy anybody, or you're like, oh yeah, I remember, this is easy. And finally, the very, very last piece of this is f of x, or the last example is f of x equals the square root of x plus 13, and g of x is equal to x squared. So I need to find f of g, but instead of x, it's a 2. That means I'm plugging in 2 at the end, or you could plug it in at the very beginning. It is up to you. I will do both real fast, and you can decide which one you prefer. So I'm going to compose them first. So I'm going to put g inside of f here, and then I'll plug in the 2 and get the answer. Or I could have done it the other way. Let's go ahead and try that. So again, the outer function is the outside one, or the first one. So the outer one is, again, the f. So this guy's our outside one, and our inner one is g. So I'm gonna go ahead and put that down real fast. The square root, but instead of x, I'm putting something there, plus 13, yes. Okay. And what what is g of x? It is just x squared, so that is going to go right there where we put that spot. So I'm going to put an x squared right there. And luckily, there's nothing we can do except plug in 2 now, because this function is simplified. I can't do anything to it. It is ready to go. So let's just plug in 2. What is 2 squared? Or I guess I could even do it mathematically. I'm going to change that that x into 2 squared plus 13. Which is what? Yes, it is 4. Sorry, I thought I was going to sneeze there. So I got 4 plus 13, that is the square root of 17. And you could simplify it more by giving me the decimal, but I don't really want to do that. So the answer to this guy is the square root of 17. And you could have done it the other way, where you plug in 2 into the g first, and then whatever answer you get, you plug it into f. But you still always plug in to g first. So if I want to do it that way and I don't want to do all this composition stuff, you could just do, well, let's figure out what g of 2 is. If I do g of 2, that means I'm taking the x off and I'm putting a 2 there. So 2 squared. So that answer is 4. So I'm going to take this answer, that 4 that I got. Oop, I'm going to do it in. So I'm going to take this 4 and I'm going to plug that in to f. So I'm going to take this answer and I'm going to take it all the way to f now. And I need to do f of 4 now, right? Because I'm taking the 4 and I'm plugging it into f. So in that case, I get the square root of 4 plus 13. Which you kind of look, that is almost the same step here. So either way you do it, you will still get the same answer, because 4 plus 13 is the square root of 17. So no matter how you play your cards, you will get the same answer. Alright, well, hopefully this made a little bit of sense. I will post these pictures again for the notes on It's Learning, probably Friday, so you'll see them there too. Make sure you take notes, and hopefully this video made sense. Y'all have a good day.